So in previous lecture, as we saw, from the X-ray tube, the X-ray beam was coming out and it was falling on the animal. After interaction with this animal, the beam comes out from the animal and it fall on the film. This film may be non-screen type, means without screen, or this film may be with screen. Which screen? Intensifying screen. So the film may be non-screen or it may be screen type. So these X-rays, they fall on the film which may be non-screen and which may be screen type. So today we'll see how the latent image is formed and then it will convert into the visible image. As this is the film which is having in the center base and both sides there is emulsion. There is emulsion. If we bring this emulsion out, this is the emulsion. In this emulsion, this background is gelatin. So gelatin is the base or the background. In this background, in this gelatin, there are crystals. What are present? There are crystals. So these are crystals. These are crystals of silver halide, which is having AgBr 90 to 99% and Agi 1 to 10%. So these are the crystals which are present in the emulsion. So today we'll see the structure of these crystals. If we look at the AgBr or Ag iodine, they form one structure that is known as a crystal. That is known as a crystal structure, crystal lattice. In this lattice, there are some defect. There are some defect. Means this lattice is not perfect. This is imperfect. This lattice is imperfect. In this lattice, the type of defect, what kind of defect are there? We call them Frankel defect. Frankel defect means, suppose this is the crystal where Ag, Br or Agi, all these are present. This is silver, Br, again Br, this is Ag, like this. In case of Frankel defect, one of the silver atom, it migrate or move in the space. This space is called interstitial space. So this is interstitial silver ion. The place from where it is moved into this interstitial space, that place is called a vacancy. That is called a vacancy, or we call it vacant defect. So in case of Frankel defect, the crystal of the AgBr is like that. One of the Ag molecule atom, it moves from its original site into the interstitial site. This site becomes empty and this site is called vacant space or vacancy. And the site where it is moved is the interstitial space. So this is called interstitial silver ion. So such type of defect, Frankel defect, they are found in the crystal of Ag Br. So if we look at the three-dimensional structure of this crystal, then these are the corner, or these are the AZ, BR, or BR iodine. But in the interstitial space, there are many freely moving Az plus ion. These are interstitial defect ion. And other structure is as compact by these molecules. So if we look at the structure of AZBR, then on the surface, Br negative or iodine negative, these halide ions are more. These halide ions, they are more at the surface. It means because of these halide ions, the whole surface of the crystal looks like negative, and the interstitial ion, they are inside. They are inside, like this. Along with this, in this structure, there is one space which is called sensitivity center or sensitivity spec. So inside the emulsion, if we look at the emulsion, this is the emulsion of the film which is having these crystals. How many crystals? 6.3 into 10 to the power 9 per centimeter cube. So these are the crystals. These are the crystals. If we bring one crystal out, then this crystal is having on the surface negative charges because of halide ion, mainly bromine and 1 to 10% iodine. Inside it is having Az plus, and inside it is having this sensitivity center. Every crystal, this crystal is also having same structure. This crystal is also having same structure. If this crystal is having this structure, then okay, this is the film with emulsion, and this is the patient from which X-ray beam is coming out. These are the X-ray photons. If we are using here intensifying screen on both sides of the film, then from this 95% light photon will be coming and 5% as such X-ray photon. X-ray photon will come and they will fall on these crystals. So these are the crystals. Emulsion of the film contains these crystals. So after coming from this intensifying screen, these photons, they will interact with the crystals. So the first step is interaction with the crystals of silver halide. As we know, the structure of the one crystal is negative on the surface and positive is inside, and there is one sensitivity center. So what happens when this light photon or this 5% X-ray photon, they fall on the crystal? we'll see the interaction of photon with the crystal. So this is the emulsion and this is the photon and this is our cubic crystal lattice. So on the outer surface, which ions are? Bromine ions are there, bromide, or some iodide also there, bromide. When this photon comes, they interact with this bromide ion. After this interaction, this negative charge will lose. It means bromide will lose its electron and it will become a neutral atom. It will become a neutral atom. This electron will now free to move inside the crystal. This electron will come to the sensitivity center. It will come here. What is left behind is bromine atom. Because this is an ionic crystal, this bromine was in this crystal lattice, this negative charge was attracted with the Ag plus and there was a bond. But if you remove this electron, if you make this bromine as neutral atom, this bromine will come out from this lattice structure into the gelatin. Outside is the gelatin. This is one crystal and the outside is the gelatin. So if photon fall on the bromide ion, it will lose its electron. That electron will go to sensitivity center and the bromine atom, neutral atom itself, it will not remain in this crystal. It will come out into the gelatin. Similarly, like this, what will happen? This is the sensitivity center. From the surface, atom will go here in the gelatin and from this electron will come here. So this, like this is the bromine atom, ion. It will lose the electron. That will come into sensitivity center. Similarly, on the surface, there is one more bromide that will lose the electron. When the photon strike on it, lose the electron will go to sensitivity center. And this atom, it will move into the gelatin. Because emulsion is having gelatin and crystals. So from the crystal lattice, it will move out. Slowly, the crystal structure becomes disrupted because these bromines, they are moving out of this structure. So what happens at the sensitivity center? If we see, this is the crystal and this is the sensitivity center. This was the bromide ion. It was giving electrons, so there are many electrons. Inside the interstitial spaces, because of the defect, Frankel defect, there are many Ag plus ions. They are attracted towards the negative charge sensitivity center. So one ion, it moves towards this center and in this center, this react with the electron and it will become Ag, silver atom. This happens at the sensitivity center. This is the sensitivity center where there were electron and it combine and form Ag. Because this silver atom, a single silver atom is always unstable. So it will again break into electron and Ag plus. or there may be chances that this silver will attract more electron towards it and more Ag plus towards it. If two atoms are there or three atoms are there, it will become stable. It will not break. So suppose as at this sensitivity center, so this is our crystal and this is sensitivity center, at least three atoms should be present. Now this sensitivity center, so at least three silver atoms should be there, and the range is usually 4 to 10 silver atoms which are reduced because of electron. So this small piece, small part then is now, it is not called sensitivity center, it is called latent image center. Latent image center, because of the collection of 4 to 10 Az atoms. So suppose there are 4 silver atoms, they are collected at this point. Why they are collected? Because they are reduced with the help of electrons. Now they are collected. So if we look this crystal in this emulsion, it will look like this. This is the complete emulsion layer, and this is 1, 2, 3, and these are 4 crystals. The photon comes, it will break the bromide, electrons comes out, and here in the sensitivity center, suppose 1, 2, 3, 4. These 4 atoms are reduced. So this crystal is called exposed crystal, and this center is now called latent image center. This is the terminology. Similarly, one photon fall on this crystal, then again same reactions happen, and here 5 silver reduced. In this also some light photon falls, 1, 2, 3, 4, 5, 6, and here also 4, 5, 6, 7, 8, 9, 10. Some photons fall. So in these crystals, silver ion is reduced to metallic silver, and in these crystals, what comes out in the gelatin? Your bromine or iodine. Halide will come into the gelatin. Why it comes out? Because this is an ionic crystal. Two ions, they are connected by the positive negative charges. If you remove the charge of one, it will become neutral and will come out of the crystal. So in this emulsion, when the photons coming out of the patient, they interact with the emulsion, whether it is light photon, X-ray photon, they interact with each crystals. Inside the crystals are example of Frankel defect. They have inside positive charges. On the surface, negative charges. Negative charges loses electron, and that electron combine with the Ag plus, and they reduced collect at one center. So these small pieces, they are called latent image center. So if we look at the condition of our film at this, so we started with the patient from which it was coming. Suppose you are using screen film, there may be intensifying screen. It will come, and what will come out? Light photon. Then we have our emulsion. Emulsion have many crystals. These are the crystals. 1, 2, 3, 4, 5, 6, 7, 8. Out of 8, only these 6 crystals are interacting with the photons. So they are reduced and they behave as a latent image center. These two, 1 and 2, they remain as unexposed crystals. Unexposed crystals. Because they are not exposed to the film. So what will be the fate of these two unexposed crystals? They will be removed by the fixer. Developer, fixer, rinser, washer and drying. So that fixer will remove these unexposed crystals. And these are called exposed crystals, exposed grains. These, when they will pass through the developer, they will become amplified, or you can say they will become visible. So at this level, they are not visible even with the microscope. These tiny structures, they are not visible. Because they are not visible, so they are called invisible or latent image. Latent image. So if we look at composition of latent image and a true image, this is the emulsion which is having these 6 crystals. Out of these 6, this is having latent image, these 4, but these 2 are not. So a latent image, invisible image, is consist of exposed crystals plus these 2 unexposed crystals. Exposed crystals are having reduced silver and they are having Ag+. But if you pass them through the developer, fixer, and you get the image, in this processing, these 2 are removed. These 2 are removed. So a true image will contain only these exposed, reduced metallic silver, that is of black color image. So a latent image which is present in the emulsion having exposed crystals along with few unexposed crystals. These exposed crystals, in one crystal, they have one sensitivity center in which at least 3 or range is 4 to 10 silver atoms are reduced. But this is microscopic, they are very small, not visible with the microscope, so they are invisible, so they are also called as latent image. So when this latent image is this is the sensitivity center, not sensitivity, this is now called latent image center. The latent image center, suppose this is the part of latent image center having 4 to 10 silver atoms which are reduced. One crystal, it is having negative charges this side. The developer is having one of its component reducing agent. This reducing agent, it is also having electrons. It is also having electrons. So this negative surface and this is also negative. So if our reducing agent wants to enter this crystal, it cannot enter from this part because negative repulsion will be there. So it can enter only through these specs, this latent image center. So this reducing agent will enter into crystal from which area where these centers are there. It will come, it will enter, and in this center only 4 to 10 are reduced. Only 4 to 10 are reduced. Suppose there are 100 of Ag plus still present. This reducing agent which is carrying 100 of negative charges, it will donate electron and it will reduce these also. So the function of the developer is to reduce the silver and make it visible, because in that latent center 4 to 10 only reduced but remaining are unreduced. So the reducing agent will come and it will donate its electron and will reduce it. And so if this is our emulsion and this is the crystal where this is the latent image where these four are present. So these four are present. Suppose this is one crystal and uh, this is the sensitivity center, but this is unexposed crystal. So unexposed crystal will have negative charges over the whole surface. So our developer which is having reducing agent, which is having negative charges, when it comes to the emulsion, from the whole surface, it will get repulsion. It means reducing agent will not enter into the non-exposed crystal, so it will not reduce these one. So reducing agent only enter the exposed crystal. Exposed means those crystal which were having X-ray photon incident on them. Suppose these were two on which X-ray or visible light photon interacted, and because of interaction, what is forming there? Latent image center form. But this crystal was not having any exposure with the photon, so it is unexposed crystal. Whole surface is negative. Our reducing agent is also having lot of electron, negative surface. It cannot come and reduce it. So it will remain as such. The fixer will come and clear it. Remove this from the emulsion. So the role of reducing agent is only to reduce these two, means exposed crystals. So these exposed crystals, they are having these centers. In exposed crystals, the remaining area, this area is also, because of some negative charge, it is negative. So the only entry point for a reducing agent is from the sensitivity area, latent image area. So it will come and reduce remaining Ag plus, and it will form reduced metallic silver of black color. So now if you pass your emulsion or your film through the developer, then the whole crystal will be like this, and it can be easily visible. So this is how a latent image is converted into a true visible image because of the reducing agent. So after this image formation, we'll see something about dark room safety light. Dark room safety. Dark room, it is having a bulb which is of 10-watt power. And the distance between bulb and working surface, that distance should be 5 feet or 1.5 meter. Then one is bulb distance and third is the color filters. Very important is the color filters. Means the filters which we are using here, they should be of. So if we look at the color of a filter, it is of two types. Those intensifying screen which are having rare earth element, they emit green light. So in that case, we are using green sensitive film. Green sensitive film. If you are using green sensitive film, then it is recommended that use red filter. Use red filter because this will filter wavelength more than 550 nanometer. More than 600, not 550, 600 nanometer. The second case is if you are using calcium tungstate as your intensifying screen material, then that will emit blue light, and in that case you are using blue sensitive film. So in that case, if you are using a blue sensitive film, the filter which is recommended is the amber. We use amber filter because it will filter the wavelength which are more than 550 nanometer. But if we compare red filter and amber filter only use with the blue sensitive film. But this red filter is suitable for both. That's why we are using red color filter in case of dark room, because red filter is suitable for both. Whether you are using your calcium tungstate screen or your rare earth metal screen, means it is suitable for both green film and your blue film. So with both you can use red. Then after so remember about dark room, 4 points. The first point was bulb 10 watt. The distance of bulb from the working surface, your 5 feet. Third point, filter. If you want to remember only one, then remember red filter. We can use it with both for blue sensitive film and for green also. And the last temperature of dark room, it should be 20 degrees centigrade, or you can say 68 degree Fahrenheit. Two different units. 20 degree. Humidity of this dark room. Humidity, it should be 40 to 60%. So these 5 points remember about the dark room. Bulb, distance of bulb from the working area, filter, temperature, and humidity. Next topic is film processing. Film processing. First is development, that is developer, then rinse with water, third use fixer and remove the unexposed part, then wash and dry. In some books, this is called terminal washing or final washing. Final washing. And in some books, this rinsing is also called early or initial washing. In ICAR 2019, they have asked one question MCQ that time for the washing. If you see this time is 20 seconds and this time is 20 minutes. 20 minutes. Washing means final washing, that is 20 minutes. Development is 5 minutes and fixer is double of this, 10 minutes. So it's simple. You can remember the main chemicals are present in developer and fixer. So this chemical 5 minutes and this chemical 10 minutes. This is also rinsing, is kind of washing also, initial washing. This is for 20 seconds and this is for 20 minutes. And drying is for 30 minutes. 30 minutes. So this time is very important. And temperature, it should be 68 degrees Fahrenheit or 20 degrees centigrade. That is very important for all. So the first step, this processing of the film, this processing is two types. One is manual and one is with the machine, that is automatic. In case of manual processing, the first step is wetting. Wetting the film. This step, wetting step, is omitted, it is removed in automatic processing. This step is not there. This step is added here in the second step, that is developer. So wetting, wetting of the film, why it is important? First remember, what is the wetting agent? That is nothing but your water. Time for this wetting is 15 seconds. Why we are giving this water for 30 seconds to the film? What is the role? Because after this, the step is development or use of chemicals called developing chemicals or developer. So for those chemicals of the next step, for chemicals to penetrate, for the chemicals to penetrate this emulsion or more important term is gelatin, because these crystals are present in gelatin. So for those developing chemicals to penetrate the emulsion, they are treated by the wetting agent H2O. So those chemicals will easily enter, and because of this, because of the wetting agent, the gelatin or emulsion will swell and it will become swell and soft and allow the entry or penetration of the chemical. So this first step is the wetting the film. So this step is present only in manual processing, not in automatic processing. The second step is the development, use of developer. What is the role of this developer? As I told, this is the film emulsion which is having latent image. The developing agent, it will having negative charges, these are also negative, it will come, enter and reduced Az plus to Az. ICAR 2019 MCQ. The reducing agent of the developer reduces the Az of latent image into metallic silver. Because in this part only 4 to 10 silver atoms are there. So their remaining are reduced by the reducing agent of the developer solution. So it will reduce. With the developer, there are two terms I want to explain here only. One is under development, one is over development. One is over development. We have film, we have emulsion, and that emulsion is carrying these five crystals. Out of these five, four are having latent image center because these four interacted with the X-ray photon, but this is unexposed. Unexposed. So if you place your film in the developer which is having reducing agent, it will reduce this. That will lead to formation of film. Then what is under development? Under development means this is your exposed crystal. This is having 4 to 10 reduced silver already. It is not completely reduced. This is the under development. Means all the Ag plus are not reduced. What is overdevelopment? Overdevelopment means you are having 1, 2, 3, 4. These four exposed crystals. These are four exposed. They are fully reduced. In addition to this unexposed. This is unexposed, which is having Ag plus in the. So this unexposed, which is having Ag plus in the interstitial spaces. Voice is clear now? Hello? Hello?
हाँ आवाज आओ है क्लियर है
Hello?
हाँ क्लियर है
Hello?
हेलो हेलो
Hello?
हेलो क्लियर आवाज हेलो
हाँ, okay. So,
Clear है, okay है.
mhm.
Continue.
So 1, 2, 3, 4. These are exposed crystal and one is unexposed crystal. So overdevelopment means these unexposed crystal which is having silver in the interstitial space, it is also reduced. And if more silver reduced means your film will becomes more black. That for that the term used is FOC, foam. So overdevelopment will lead to the reduction of these unexposed crystals also. So these are the two terms where underdevelopment means these exposed crystals with the photon of light they are not completely reduced, and overdevelopment means these four are totally reduced, along with that this unexposed is also reduced partially. Then if we see the composition of developer, if we look at the developer, as I explained, time 5 minutes, temperature 20 degree centigrade or 68 degree Fahrenheit. The first component is the reducing agent. Reducing agent. There are two reducing agents. One is phenidone and one is hydroquinone. These two, voice clear na?
हाँ, okay.
Hello.
Okay है.
Clear?
हाँ.
Hello.
Hello, okay है.
Hello.
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 हाँ, hello.
Hello.
हाँ, hello. Hello.
Hello.
Hello.
Hello. Hello.
Hel- Hello. Hello.
Voice.
Clear है आवाज.
Voice is not clear. Hello.
हाँ, clear है.
Hello.
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 हाँ,
Clear no?
okay है. Clear है.
So the developer, time for the developer is 5 minutes, temperature is 20 degrees centigrade, and the reducing agent are two. One is phenidone, one is hydroquinone. The difference between these two reducing agents is, as the name itself pH, phenidone, PHAST means fast. Fast. This is fast acting, and the hydroquinone, because it contain long name, so you can remember it like that, it will take long time, means it is slow in action. So there are two. Phenidone is fast and hydroquinone, the material with long name, it is long, taking long time, so it is slow in action. So these reducing agent, as I explained, they reduce the remaining silver of the latent image and help in formation of a true image. The second composition of this developer solution is the activator. Activator. This activator is nothing but your Na2CO3 or NaOH. This will make the pH alkaline. It means the developer is alkaline in pH because of sodium bicarbonate. So it stabilizes the pH and make the pH alkaline. So activator will make it alkaline pH. Second, the activator also help in swelling of the gelatin, that is emulsion, which help in better penetration of chemicals into the this emulsion. The third component of this developer solution is the restrainer. This is restrainer. Restrainer will restrain or it will stop. It will stop the reduction of unexposed crystals. So as I explained, the emulsion is having two types of crystal. One are exposed by the light, that is photon, and one is unexposed. So these unexposed will not get reduced. So who will stop their reduction? Restrainer, that is potassium bromide or potassium iodide. It will stop, it will restrict the action of developing agent like hydroquinone, phenidone to reduce this unexposed, because these were not exposed by the photons, so these will not get reduced. So who will stop this reduction? Restrainer. It will stop the reduction of unexposed crystals. This is the, so if we use a developer, without restrainer, then what will happen? Without restrainer, then from the film, both exposed as well as non-exposed crystal will get reduced. So normally this is the emulsion which is having these 5 crystal. Out of these 4 are exposed by the light photons, this 4, but this is unexposed. From the developer solution, the reducing agent will reduce these 4. It will reduce Az plus to Az, only these 4. Who will stop the reduction of this? This is the restrainer. Who is restrainer? KBr, potassium bromide. If we remove this restrainer from the developer solution, then this 5th crystal will also get reduced, because this crystal in the interstitial area, it is having Az plus. Although it is not having any latent image center, but still because of defect, it is having interstitial Az plus. So if you remove the restrainer, then this unexposed will also get reduced. So to stop the reduction of this, because it is not, if this is unexposed, means from the patient no information is coming to this crystal, this grain, so it is not going to carry any information on the final visible film. It will only make it black, but this is carrying the information. So we want to stop this here only. So that job is done by the restrainer. Why it is necessary, or if you remove restrainer, what will happen is the reduction of unexposed part. Next is the preservative. Next is the preservative. The preservative itself, it prevent the oxidation of reducing agent like hydroquinone. It prevents the oxidation of the hydroquinone by the air. From where the air is coming? During the preparation of the film, if there is air is present or in the solution air get mixed, then it will lead to oxidation of our reducing agent. So to prevent that, we use this preservative. The name is sodium sulfide. Sodium sulfide or sulfide. It will prevent the oxidation of our main reagent, that is reducing agent. So this was about developer. If we see about the developer solution, three things are more important. If you remember only three things. First is time, your 5 minutes. Second is temperature, 20 degree, that is 68 Fahrenheit. And third is the concentration. Third is the concentration. What happens if we use high concentration of the developer? If the concentration is increased, it means you are increasing reducing agent in the solution. This reducing agent becomes more powerful, and this reducing agent will enter and it will reduce these four exposed crystals plus this fifth one also. It will also reduce this because you are using high concentration. High concentration of developer carrying high concentration of reducing agent. So not only reducing these four, it will also reduce the fifth one. So the fifth one is also get reduced. So concentration is also equally important. If we increase the developer time, in LDO 2019 there was one MCQ that the temperature is 20 degrees centigrade. They said if we increase the temperature, then what will happen? So if you increase the temperature, this development time will be less than 5 minutes. Means development time will become less. So the film will develop in less time. So after developing, the next step is rinsing or washing with water. Time is 20 seconds and temperature is same 20 degree centigrade. And here in rinsing we can use acetic acid also. Acetic acid, and that is called as stop bath. The meaning of this stop bath means this will stop, this acetic acid will stop, this will neutralize your developer, because now you are going to fixer, so it will neutralize the developer and we want to stop its action. So from the developer, from D to F, there is one step R, rinsing with the water, or we can use acetic acid, that is called stop bath. Why stop bath? Because it will stop the action of the previous chemicals, that is developer. It will neutralize it and stop its action. So called it stop path. So after developer rinsing, we come to fixer solution. This fixing solution, first it contains activator. It contains activator. Activator is nothing but the acetic acid. This is similar to the rinser acetic acid stop bath. If you use water only in this step, then it is okay. Because in the next step, the fixing solution itself having its activator having acetic acid that will act as a stop bath. It will neutralize the previous chemical from the developer solution and stop their action. Because this is the time for the action of agent of this solution. So after activator, the main is the fixing agent. Fixing agent. So in developers, those crystals which were exposed, they have reduced. So this fixing agent, it is also called clearing agent. Clearing agent. Why it is called clearing agent? Because in the film, the role of developer is over to reduce these four. The fifth one was unexposed. So this clearing agent, fixing agent, it will clear the fifth one, that is unexposed crystal. It will clear unexposed crystal from the film. Then the example of this fixing agent is sodium thiosulfate. This is commonly called as hypo, Hypo. Sodium thiosulfate is also called hypo. After fixing agent, the third component of the fixer solution, third is the hardener. As the name indicates, it will make the film hard. What is the need? Why to make the film hard? Because if you look at the film emulsion, suppose these four were reduced and these three are there unexposed, the fixer removed these. These are removed by the clearing agent, fixing agent. So the crystals are going out of the emulsion. So emulsion will shrink. Emulsion will shrink. This hardener, it will accelerate. It will accelerate this shrinking. It will accelerate this shrinking. It will make it more hard. So after developer, fixing agent removed these three. After removing these three, the emulsion is having few crystals. Emulsion keep on shrinking. If we add hardener, it will make it more shrinkage, more hard. Then what is the purpose? Why to make it more hard? Because developer, rinser, fixer. After this, the steps are washing and drying. To go into these two steps, we need our emulsion shrink and become hard. So that our film is properly transported. Film is properly transported through washing and drying section. So we want to make it hard by using hardener, that is nothing but the ammonium chloride. So we make it hard and we can easily, if it is soft, then there may be chances of damage. because the next steps are washing and drying. Then the fourth component of this is also preservative. Same in the developers, preservative same, and action is also same to prevent the oxidation. To prevent the oxidation. And this is your sodium sulfite. It is same to both. It prevents the oxidation. So after fixing, once you have removed all the unexposed crystals, will go for washing. Will wash for 20 minutes. That is also called final washing or simply as wash. And after this, will dry the film. Drying will be of 30 minutes. 30 minutes. So this completed our topic, film processing. So if I summarize the film processing, what happens? We started with the animal. From the animal, the beam is coming out. Suppose this is screen film, which is having screen, fall on the screen. From the screen, below it is film. The main part is emulsion. So this photon, suppose the emulsion is having five crystals. This photon they fall on the four. So these four are exposed with the photon, and we call this one is as unexposed. Unexposed. Then we take this film and put into our developer. From the developer, the reducing agent, hydroquinone or phenidone, carrying negative charges, it will come and further reduce these four. It will reduce. So you will get metallic silver. Then what you do, you keep your film in fixer. In between you have rinsing with water or stopper. You put into fixer. Fixer is having fixing agent, clearing agent that will remove this part. This will remove this part from the film, unexposed part, the fifth one. So now you will get 2, 3, 4. You will get only these four crystals which are having all the silver in the form of, which is reduced in the form of metallic silver, and it is carrying information because from the patient these photon fall on these four. So these four are totally reduced, fully reduced. These are carrying the information from the part. Suppose this is thoracic radiograph. It is carrying all the information in the form of these four spots. They are reduced fully, and you will get black color film. So from the patient, they fall on the intensifying screen, which generated more number of photon, intensify the photon, interact with these four, becomes exposed. One is unexposed. Then we keep put into developer. Reducing agent is there, which fully reduce them into metallic silver. Then fixer, it remove the unexposed fifth one. Then final fill, it is processed, wash it and dry it. This was the film processing. So during this processing, from the developer, rinsing, fixing, washing and drying. If you increase this solution, increase the time, then film fog will be there, more deposition, underdevelopment, overdevelopment. If you keep more fixer, if you remove the restrainer, then all become black. If so, if there is any error in these processes, that may lead to formation of artifact. So you can read the book that if we using high temperature, if we using old solution of developer, old solution of, if you're using developer for long time, then which artifact will be there? If you are watching and some damage occur, then which artifact is there? So these are the artifacts. This finishes our